In this video, I'm going to explain the enclosure command, and the enclosure command is the one of the most important commands in Design Modeler. And basically, this is the main point of the software, I would say. So basically, the enclosure command will create the domain around your object, that is your body of interest. This can be the aircraft, this can be the circular cylinder, this can be the car model, or anything around which you want to analyze the fluid flow or heat transfer. So, in other words, this will create the control volume around the body of interest to solve the fluid flow and heat transfer. And if you take a look on the command, so you can find this command from the tools menu, and then you have to click on the enclosure. And there are the multiple options like the box, cylinder, and sphere. Box, sphere, cylinder, and also you can create your own body and use this one as the enclosure. So you can create the body separately with the help of the primitives or sketching and then extrude command, whatever you use. And then you can use that one as a custom enclosure. So there's the option also there. And if you take a look on the other options, the number of planes. The number of planes, basically they are used for defining the symmetries on the around the geometry. So for example, I can define the symmetry on this geometry by dividing the geometry from here. So this will be a only 1/2. But definitely I will not do this thing because this cylinder, when I analyze this cylinder in CFD, this will be creating vortices and they are 3-dimensional. So symmetry would not be helpful here. But for the aircraft model or for the any car or bus model, this will be very much helpful. And the question you can create is the uniform. Uniform means that every side this will be equal, but non-uniform means that you can change the dimensions in X, Y, and Z, both sides, minus and plus also. And then you have to choose the target bodies. And right now it's only single body. There may be multiple bodies, so you have to select all bodies if needed. And then this command is very important. This command basically is linked with the name selection. So if you say export enclosure, so what it will do is that it will export the if there's some symmetry, and the remaining boundaries which are here, they will be exported as open domain. But if you say no, this will not happen, and then you can define your own boundary conditions with the help of the name selections. So I will show you this thing also. Okay. So you can now define your own name selection. You can export them to the meshing software. Okay. So we have the two examples. One is the domain around the one aircraft, same aircraft which we used earlier, and second one is the domain around the ML body. Okay, so first of all, we are going to create a domain around the sphere, and I will discuss about all the options available there. So first of all, we are going to create a one sphere, and I will keep everything as a default and click on generate. Okay, so you can zoom your geometry and see the geometry we have just created. Okay, now I will go to the tools, and from here I'm going to select the enclosure command, and here it is. So we have the many options like the cylinder, sphere, and user defined. I will explain one by one. So if you create the box and click on generate, so this box will be created. And the question right now is the 1 meter from the boundary of the geometry. So you can see here. See, this is the 1 meter from the every side. Okay, and now if I right click here and edit selection, so there are two options. One is the uniform, and here it will be only a single value for the all dimensions. So this will be the uniform across all the dimensions. But if you change this to the non-uniform, you will see that you can set them separately. For example, here in the x direction, I set the +5 and -2, So let's see what happens. So this happens with this thing. Okay. But once you create, this is very important. Once you create the your enclosure, then you have to suppress the geometry of the your main body. So now you can see that we have only a surface around that geometry, that is the where the flow will be going over through it. Okay, not through it but over the body. So only we need the outer boundary of that particular object. Okay, now you can see that we have this thing over here. So if I again add it, and this time if I choose a number of planes to be 1, okay. So let's say that this is going to be the xy plane, which is vertical plane here, and so select the plane and click on apply and click on generate. So you can see now only half of the model is there. Only half of the model is there. And also we have the export enclosure command is enabled. So if I create the meshing here, so I'm not going to create the mesh, but I'm going to just show you that what will happen when you export the geometry to the meshing software. So with these conditions, that export the enclosure, this will give you the some boundary conditions. One is symmetry, and the second is this enclosure command, that is open domain. So the rest of the conditions, like the inlet outlet, you have to define yourself by clicking on the name selection. So you have to click on the boundary and right click and click on name selection, then you have to choose, let's say, inlet. Okay. So now let me show you that what conditions we have right now here. So this is the open domain, which is these 3 boundaries, and the symmetry plane, which is here. And but if there is no symmetry plane, in that case, what will happen is that if there is no symmetry plane, what will happen is that we are going to get the 1 minute. So we are going to get the only open boundary. Okay. So now let me show you in the meshing app. So right click on the model and click on update geometry from the source. So we have the open domain, and and this is the inlet. Okay. So right now it is having all the boundary conditions here. Okay. Now we change the option, and so if I right click here, edit selections, and if I say don't export the enclosure, okay, so said no, and now in the meshing app, right click here and click on update geometry from source. So we have only one boundary condition that we have decided by ourselves, and now you have to give the boundary condition or name selection for these boundaries yourself, either in the meshing software or geometry software, but I would be recommending that you should be doing that thing in the geometry. Okay. Okay, so we have done this one case, and also I want to explain that what will happen if I define the 2 symmetry planes. Okay, so let's say we have the 2 symmetry planes now. One is the XY, and the second one is, let's say, is going to be the XZ plane or ZX plane. Okay, second one is the ZX plane. And click on generate. So this happens. So we have now only a quarter model. So with the 1 symmetry, the model is going to be the half. With the 2 symmetry, this is going to be the quarter model. Okay. So now we work on the second case, which is the aircraft geometry. This geometry is after cleaning. I explained in the I think the previous to previous video, and I removed the fins on the wing. Okay. So now we are going to create the domain around this geometry. So click on enclosure, and this is going to be this time, let's say one is I'm going to create is a box. So in the y direction, because the axis of the flow is in the y direction. So let's say I define this to be the 5 and minus y is 2. So click on generate. Okay, and make the frozen body transparency visible. Okay, this was done in the, should be done in the y direction, not in the x direction. Okay, so this is now correct. Okay, you can see now our geometry of Boeing 747-400 is inside, and this is now domain around this geometry. Okay. Now I told you that you have to, once you create the enclosure, you have to suppress your main geometry, that is the around which we have created the that particular box. Okay, so now the next thing is that I'm going to create the my own defined enclosure around the geometry. So for that I'm going to use the another geometry case, and that is going to be the MN body. So I'm going to create, I'm going to import the geometry, and that is going to be the MN body. So this MN body is over here. Okay, so we have just imported geometry for the MN body, and let me show you the dimensions for the domain quoted in the literature. Okay, so you can see that there are the few things here. One is that the length of the geometry is taken as a L, so which is 1044. You can see from here is 1044 millimeters. So length of this one is a 1044, so 5L and 7L, and then this is a vertically is a 3L, and width is also 3L. And one more thing is that this is the symmetric model, and also axis is placed on the this bottom part of the geometry. Okay, and x-axis is on this side, and z-axis on this side, and y-axis on this side. Okay, so let me try to create the custom type of the geometry here. So the first thing is that I'm going to use a symmetry boundary here. So the symmetry boundary is going to half the model. So I'm going to use a symmetry model right now. I'm going to use this is going to be the ZX plane. Okay, so ZX plane. And I don't want to export symmetry by the design model. I want to create my own boundary conditions if necessary. Okay. Okay, there are two things that you can learn in the symmetry boundary condition. One is that the full model, and second the partial model. So this will be like making the things on this side or this side. Okay, so if you do this thing, you'll get the model on this side. Otherwise, now let me show you again. So this is the partial model, and this is the full model. Okay, so take a look on the geometry. So this is the showing on this side, but if you take a look from the inflow, this will be on this side. Okay, this will be on this side, which is shown exactly here. So if you take a look from the other side, like here, this will be similar. Okay, like this. Okay, now the important thing is that this is the x direction, the y direction is over here, and the y direction is here. This is same exactly as this one. The only thing is that now this geometry should be having the, this point should be at the origin. Okay, so first of all, I'm going to use analysis tools, and from here I'm going to get the entered information, and this is going to be the from the this vertex. Okay, so this vertex over here, and this shows that we have the x-axis is 1.1235 and the y is 0 and the z is 0.05 and the 0.05 y, so see this thing 0.05 because this is at the 50 millimeter from the bottom. Okay, so again let me show you this model here. Okay, so this shows that this axis is on the bottom side, not exactly on the geometry, but this is on the bottom side. Okay, so it should not be exactly on the geometry. Okay, so now we follow this thing here, and I'm going to move this geometry by distance of 1.1235. Okay, 1.1235. Okay, so I'm going to use the body transformation, and I will use the translate command, and this is going to be my main body. And then direction definition is from the x-axis. So I will choose the YZ plane, and that's going to be on this side. Okay, on this side, no, on the other side. Okay, and how much? This is going to be the 1.1235. Okay, over here, like this. Okay, now click on generate. Okay, now I'm going to create the geometry for the domain. So I'm going to create a sketch. That sketch would be on the ZX plane. So I will choose a ZX plane, and then I will click on the create sketch. So sketch is here. And now from sketching tab, I'm going to first click on look at. So it should be in this way. Okay, so I'm going to create the line. So this line would be from here to here. Then from, and also keep in mind that it should show you the P symbol when you click on the point. So P symbol, and then over here, and then also from here, so should be P symbol here. Okay, so I'm going to create the dimension. So from this one, this is going to be equal to 1.044. 1.044. This is exactly equal to length of the geometry. So it should be 1.044. Okay. Okay, so the next one is going to be the 2L. So the second dimension, which is over here, this is equal to the 2L. So no, sorry, this is right now here in this model is a 5L. In some cases, a 2L, so you have to follow the paper you want to validate. So it's a 5L here and 7L on the downstream side. So 5L would be equal to, so 5 into 1.044 is equal to 5.22. So 5.22. Okay, on the back side, this is going to be the 7L, and 7L means 7.308. 7.308. Let me confirm again, 7.308. Okay. Then vertically, this distance is equal to 3L. So 3L would be equal to 3.132. Okay, so let me draw the vertical line, and this line is going to be this one. Okay, so dimension for this geometry is going to be the 3L, and which is equal to 3.123. 3.123. This is H4. 3.1 3.132. Okay, so now I'm going to create the one more line here, and this line will be longer than the line up to point here. So like this, and then I will be vertically creating a line from this point, and I will make it like this. Okay, now I will use the modify menu from the sketching tab, and then I will click on the trim. So I'm going to trim the extra parts from here, and also I'm going to trim this geometry, this line, and this line as well. So I'm going to create single line basically from these two ends of the domain, like this. Okay, so now we have this sketch, and right now I'm going to make the extrude command, and this time this should be add frozen, so that it will not be merged with the geometry over here. Okay, and this should be equal to 3L, and let me check how much it is. So 3L. So 3L will be equal to 3.132. 3.132. So this my domain is right now here. So I will click on the generate. Okay, so now we have our custom domain with us, and I'm going to use the now enclosure command, and here I will choose my user defined geometry from here, and the geometry I'm going to use, this one is going to be this boundary here. Okay, and I'm going to select the body for this around which we are going to create this domain. This is the body of the ML body. And do you want to export enclosure? So say no for the exposure export, and now click on generate. Okay, so I'm going to suppress this geometry from here, and then you can turn off the frozen body transparency. You can see that we have the domain. That is the split, after split of the means that inside body of the ML body is not included, so only the surface body around which the flow will be going over is there. So in this way, basically we made the geometry for this domain. So if you want to hide, you can hide this face, and you can see the things from inside as well. Okay, so in this way, basically you can export your enclosure with your main geometry inside there. And also we have right now we have defined our own geometry for the enclosure that is user defined, and before that we created that geometry around that one which is over here.